Hi, and welcome to Growing Possibilities. On today's episode, we're going to talk about P-solubilizing biotech. First, we're going to go back and take a little bit of a refresher on phosphorus. What is it, and why is it needed by plants? And to help me out with that is a smart man wearing a lab coat. He's our research coordinator. I forced him to do this video, Jeremy Voth. Take it away, Jeremy.
Thanks, Rick. I'm here to talk about phosphorus, which is an important element in agriculture and performs many biochemical functions in plants. Some of the more important functions include acting as a critical building block of DNA and RNA, having an important role in photosynthesis, and helping with the transfer of energy throughout the plant. Phosphorus also aids in the growth of healthy plants by stimulating root development, encouraging flowering and seed production, and maintaining the overall health and development of the plant throughout its life cycle.
Thanks, Jeremy. So phosphorus is found everywhere. Here on prairie soils, it's found in concentrations of anywhere from 400 to 2,000 pounds per acre. But a lot of that phosphorus is bio-unavailable to plants, and that's for a couple reasons. The first reason is that it's physically unavailable. Phosphorus is physically very immobile in the soil, so only the phosphorus that's near the root zone, rhizosphere, is available to the plant. And the second is that phosphorus can become chemically unavailable. So phosphorus tends to bind with iron in low pH soils, aluminum in medium pH soils, and calcium in higher pH soils. There's steps that farmers can take in order to counteract this. One of them is liming the soil in order to adjust the pH. And of course, they can apply more phosphorus. So they can apply manure, rock phosphate, or chemical phosphate fertilizers. However, even when commercial phosphorus is applied, there's a lot of literature that shows that less than half of it is available to plants. This is why farmers are looking towards microbial solutions to solubilize this P. So P-solubilizing microbes have always existed in nature. P gets locked up in the soil, and this is a good thing. It stays naturally in the soil for long periods of time. This is by design, and these microbes come along and they break these bonds of the phosphorus to the aluminum, the iron, the calcium, and that makes it available to plants. But this whole process, it takes a long time in nature, and it's not efficient enough to be used in commercial agriculture. So how do we take that natural process and make it into a technology? Well, we take those microbes and we concentrate them into an inoculant. Excite Bio Plus right here. This gets applied directly to the root zone of the plant, and it makes the phosphorus that's in the soil, the phosphorus that's applied, more bioavailable to the plant. And this helps the plant to grow healthier roots, to get an earlier jump, and ultimately to hopefully produce a higher yield. And this can work on all kinds of different crops. It works on legumes, oilseeds, cereals, tubers, even veggie crops. So this type of technology has huge implications for agriculture, and it can be applied all across the spectrum of agriculture. On the next episode of Growing Possibilities, we're going to take a look at the how. So how these microbes solubilize phosphorus, and then how this naturally occurring microbe gets made into a commercial inoculant technology. Thanks for watching. Till next time, this is Rick Clement wishing you healthier plants and better yields.